Now that we know the parabolic transformations and we know how to graph a parabola using transformations, I'm going to show you a shortcut to graph a parabola just using the vertex and the step pattern. So your first step, when you get your equation, it should be in vertex form. And then let's state what the vertex is. So for this first example, y equals 2, x minus 3 squared minus 4. Hopefully we know that the vertex is positive 3, comma negative 4. And that should make sense because based on our transformation knowledge, we know that this parabola should be shifted to the right 3, down 4. So let's go ahead and plot this vertex. There it is. Now, let's identify the step pattern. And this all depends on your a value. The a value of this parabola is 2. Now, the original step pattern is the step pattern for your parent parabola, which is just 1, 3, 5, and it goes on forever with all the odd numbers. But now we're going to double this. So we're going to multiply all of that by 2. So 1 times 2 is 2. 3 times 2 is 6. 5 times 2 is 10. So we're going to now apply this step pattern to the vertex. Now when you're applying your step pattern, remember your right-left movement is always by 1 unit. It's your up-down movement that relies on the step pattern. So let's try this out. From the vertex, I'm going to go to the right one, up 2, because that was my first step. Now I have to go to the right one, up 6. Here we are. And then we would go to the right one, up 10, but that doesn't fit on my page. And now I'm going to do the exact same thing on the left. To the left one, up 2. To the left one, up 6. And then I'm going to connect my dots. And because I only have one parabola, I don't have to worry about labeling it. And that's it. You use your vertex and you use your step pattern. That doesn't mean that your knowledge of transformations isn't important. It's very important because transformations allow you to do a logic check here. You know that your parabola should open up. You know that the vertex should be to the right 3, down 4. And you know that it should look vertically stretched, which it does. Now, let's also state our domain and range here. We know that for a parabola, the domain is always x is an element of all real numbers, meaning x can be anything. And then for our range, because my parabola is opening up and the optimal value is negative 4, everything has to be above negative 4. So the range is going to be y is an element of all real numbers such that y is greater than or equal to negative 4. All right, let's try some more examples. So for y equals negative x plus 5 squared plus 2, the vertex should be at negative 5, comma 2. So I'm going to go ahead and plot that point. Now here, I recommend you do some color coding or some labeling because we are going to have 3 parabolas per grid. Next, for our step pattern, which I'm just going to shorten as SP, I'm going to take that original 135 and multiply it by the a value, which is negative 1. So that means it's going to be negative 1, negative 3, negative 5. And a negative step pattern just means when you move to the right one, you're going to go down that step. So let's try it out. Right 1, down 1. Right 1, down 3. Right 1, down 5. And moving down should make sense because we know that when our a value is negative, we have a reflection over the x-axis and our parabola should open down. And we achieve that by moving down with the step pattern. Now I'm going to do the same thing to the left. Left 1, down 1. Left 1, down 3. Left 1, down 5. And then we can connect the dots. And here I am going to label this parabola. Y equals negative x plus 5 squared plus 2. And then a logic check. I hope my vertex is negative 5 too. It is. Hopefully it opens down. It does. And it shouldn't look stretched or compressed. Great. Okay. Let's go to the next one. And I'm going to choose a different color here. My vertex. There's nothing here inside the bracket, which means there's no right-left movement. So my vertex is 0. comma, -7. So I'm going to go ahead and plot that point right there. And now I see that my A value is 2, so my step pattern will be doubled. So instead of 1, 3, 5, it's going to be 2, 6, 10. And it's positive, so we're going to be going upwards. So to the right 1, up 2. To the right 1, up 6. To the right 1, up 10. You just go a bit off the page. And then same thing to the left. Or you can just use your symmetry. Left, up 2, up 6, up 10. And now we connect our dots and of course put arrows at the end and then label the parabola. There it is. And now I'm going to do one more, and then I'll leave the last 3 for you to try and then come back to the video. So for this last one, we technically have +0 at the end if you want to see it like that. So our vertex is +3, 0 because you're actually shifting to the right 3 and you're not moving up or down at all. So I'm going to go ahead and plot that point. Now my A value is 1/2, which I'm just going to rewrite as 0.5, and I'm going to multiply that by 135 so that I get 0.5, and then 3 times 0.5 is 1.5, and then 5 times 0.5 is 2.5. So now let's go ahead and do that. To the right 1, up 0.5. To the right 1, up 1.5. To the right 1, up 2.5. And then the same thing on the left. And then we can connect our dots, and we already see that this is more compressed than our other graphs. And then I'm going to label it, of course. And there we are. Now, something I forgot to do for all of these examples is state the domain and range, so I'm going to go ahead and do that now. So for my blue one, and for all of them really, my domain is x is an element of all real numbers. And for my range, everything is below 2. So y has to be less than or equal to 2. For the green one, the domain is also x is an element of all real numbers. And for the range, if we look at our graph, everything is above -7. So y has to be greater than or equal to -7. And finally, for the red one, the domain is x is an element of all real numbers. And the range, my vertex is right on the x-axis, so y just has to be greater than or equal to 0. And there we are. Now, these last 3, I want you to try them on your own using this shortcut and identify your vertex, identify the step pattern, and then graph. So I want you to pause the video, try this next one, -3 x minus 5 squared plus 10. State the vertex, state the step pattern, do it on your grid, label it, then state the domain and range. Then I want you to come back and check your work before you go on to the next one. All right, so your vertex should be at 5, 10. And our step pattern is -3, -9, -15. I took that 135 and multiplied it by -3. So I'm going to show you again how to apply it to check your work. So to the right 1, down 3. To the right 1, down 9. And then to the right 1, down 15. That doesn't fit on our page. Then we do the same on the left. Connect and label. Now for your domain and range, you should have x is an element of all real numbers, and then for your range, y has to be less than or equal to 10 because your parabola is opening down. Now, if you got it right, great, move on to the next one. If you made a mistake, see where you went wrong and fix that mistake before you try the next one. So pause the video here and try 4x squared minus 10, and then come back to check your work. All right, so your vertex should be 0, -10 because you're not moving right, left at all. Your step pattern should be 4, 12, 20. That's that 135 times 4. So I plotted my vertex at 0, -10, and then I went to the right one, up 4, right one, up 12 to get to 6. And then the same on the left. Domain, x is an element of all real numbers, and for your range, y should be greater than or equal to that -10 because everything is above -10. And our last one, again, pause the video, make this one perfect, write that vertex and step pattern, and then graph it and state the domain and range. All right, so your vertex should be -6, 4. The step pattern, multiply that 135 by -1/3, turn it into a decimal so you can visualize it better. So -0.3 repeated, -1, and -2.6 repeated. So I plotted my vertex at -6, 4, so to show that shift to the left 6, up 4. And then I estimated a third down, then 1 down, then 2, and the 2/3 is right there. Connect the dots, and then your domain is x is an element of all real numbers because those arrows show that it extends forever to the right and left. And then for your range, everything is below 4, so y is less than or equal to 4. And that's it for your graphing. Use the vertex, use the step pattern. Now you can use this method if the shortcut is allowed, otherwise you might have to show your full transformations.